am Dr. Rizwana, working as a Professor of Physics in Institute of Aeronautical Engineering. Today we are going to discuss about outcome-based education. So what is outcome-based education? And there is a language which we use in order to frame outcome-based education, that is called as Bloom's Taxonomy. What is Bloom's Taxonomy? What are the different levels of Bloom's Taxonomy? And how we can take this outcome-based education for a particular course. And in that course, there are many things like course outcomes, course learning outcomes, and program outcomes, program specific outcomes, and how these course for a particular course, outcome of that course, how they are mapped to outcomes of a particular program. And also in the end, we are going to discuss what is the evaluation methodology used for exam system, especially first BTech examination pattern. So coming to this outcome-based education. Now, as you can see at present, this outcome-based education, which is simply called as OBE, is widely used by all leading institutions across the world. And usually when we talk about this OBE, it is a student-centric educational model that is most important. So it focuses on student-centric educational model. And here we map as well as measure students' performance at every step. That is the main goal of outcome-based education, which was lagging with the traditional educational system. And then also this coming to OBE model, it aims to maximize student learning outcomes by developing their knowledge and skills. And also this system, OBE system, it is also referred as standard-based education, which has proven to be a success in helping institutions measure their learning outcomes and at the same time enabling students to develop new skills that prepare them to withstand global competition. Okay, so they can stand out with their global counterparts. And also, what you will observe here is when we once make our students thorough with such potential, then we'll observe that these factors will contribute in raising the education standard as a whole, and also it will help institutions to acquire accreditation from esteemed accreditation bodies such as NAC, NBA, and when we go for NAC and of course NBA, what you can observe here is when they go for their educational system according to outcome-based system, then they'll prove their educational system to be one basic standard education, and it will help us to improve them continuously in the long run. And then next, when we try to compare outcome-based education with traditional education system, as you can see, this particular representation which I kept in this slide, of course, it is taken from Google. Now, what we are going to do, we are going to compare outcome-based education as well as traditional education system based on these three factors. So, what are those three factors? First factor is curriculum planning and designing, and second one is teaching process, and third one is final outcome assessment. Now, when you talk about traditional education system, which was going on in the last years, so here, when you talk about curriculum and curriculum planning and designing, what you will observe here is in traditional education system, same curriculum will be passed from previous generation to next generation, and there won't be any improvement based on student-centric learning. And also, when we are talking about teaching process, here teachers, they are more focused on completion of syllabus by the end of the semester or by the end of academic year or by the end of the session. And also, what is the final outcome assessment done based on traditional education system? Final assessment or students' knowledge assessment, it is done as per their grades obtained. So, completely it is based on final grade achievement. But whereas when we talk about outcome-based education, so when we are talking about curriculum planning and designing, so here curriculum is planned and designed according to needs of today's students. So every year there will be change in curriculum in order to satisfy students' need and according to the present status. And also, when we come to teaching process, what you will observe in outcome-based education is teachers are focused on helping students develop new skills. So, always students, not just completion of the syllabus, but from their syllabus, they'll help students so that they can develop new skills and they'll be able to withstand global competition. And when we talk about final assessment of students, here final assessment is done on the levels that track their learning and skills, which is completely opposite to assessment done in traditional education system, where we focus only on exams. But when we talk about OB system, we focus on levels that track their learning and skills. Now, when we are talking about outcome based education, here there is one global language for outcome based education, and that global language, it is called as Bloom's taxonomy. So what is Bloom's taxonomy? Bloom's taxonomy, it is an arranged ordering of cognitive skills, so that can, and of course this Bloom's taxonomy, it has countless other uses, but when we are talking about student centric learning, it will help teachers to teach and students to learn. And this Bloom's taxonomy, it has got 6 levels. Coming to first level, we have remember. So what is remember? Suppose I have taken some activities, the activities that will come under remembering level. Suppose if we are memorizing a poem, or we are recalling state capitals, or we are remembering math formulas. And then second level, see, we are going from lower level to higher level. So what is our lower level? Lower level is remember. Okay, where just we try to recall knowledge which we have studied earlier. And then second step of Bloom's taxonomy is to understand. And I have taken some activities at this level. As you can see, suppose when we are talking about this botany or geology, here we organize the animal kingdom based on a given framework. Also, illustrate the difference between a rectangle and square. Here student, he will recall what is a rectangle and what is a square, and then he is going to understand, okay, structure of a rectangle and square by illustrating their differences. And the next, one more example is summarizing the plot of a simple story. Whereas memorizing a poem is the level of remember, whereas summarizing the plot of a simple story is nothing but understand level. And then coming to third level of Bloom's taxonomy, apply. Okay, so this is third level. And some of the activities at this level are use a formula to solve a problem, and select a design to meet a purpose, and also reconstruct the passage of new law through a given government or system. So these are some examples that can be done under apply level. And then coming to 3 more levels, fourth level. Fourth level is, of course, analyze. Fourth, okay, level is analyze. And what are the activities we can take as examples? Identify the parts of democracy, and then explain how the steps of scientific process work together, and identify why a machine is not working. So all these activities, they will come under higher level, and that fourth level is analyze. And then coming to fifth level is evaluate. And some of the activities under evaluate are make a judgment, recording an ethical dilemma, and then interpret the significance of a given law of physics, and illustrate the relative value of technological innovation in a specific setting, a tool that helps recover topsoil forming. So these are some of the examples which will come under fifth level of Bloom's taxonomy, that is nothing but evaluate. And the highest level of Bloom's taxonomy is to create topmost level. So we have started from the bottom. What is the bottom level? We have remember. And then next level is, of course, understand. And then coming to third level is going from the bottom. Third level is to apply. Whatever knowledge we are gaining, we are going to apply it. And then next we have analyze. And then coming to fifth level is evaluate. And then coming to last, topmost level of Bloom's taxonomy is create. And what activities we can take under create, like designing a new solution to an old problem. Okay, so that is going to overcome previous failures. And then delete the least useful arguments in a persuasive essay. And then write a poem based on a given theme and tone. I hope you people are able to understand different levels of Bloom's taxonomy. Using this language of different cognitive skills, we are going to structure our outcome-based education. Now, In this video, now what I'm going to do is engineering physics course syllabus. So if we go for engineering physics, which is there for first year of BTech, and what we are going to do, we are going to frame this engineering physics based on outcome based education. So our course is engineering physics, and this course for different programs. So what are the, like, of course, for a program, here we are talking about BTech engineering graduates. So how this engineering physics course, how we can relate it to BTech program, that we are going to do it now completely based on outcome based education. So that will come under course descriptor. So now what I'm going to do in my next slides is, first I'm going to consider 4 levels of outcomes from outcome based education. So here, first level is program educational objectives, which are simply called as POs. And then we have program outcomes, which are called POs. And third one is program specific outcomes, PSOs. And fourth one is course outcomes, COs. So when I'm talking about, so let me make it clear. So program, when I say program here, because I'm focusing on engineering graduates. So BTech is our program. So for that BTech, what are the educational objectives? What are the outcomes of a particular BTech, so of a BTech program? And when we talk about program specific outcomes, then we are talking about different branches under BTech. So like aeronautical, computer science, electronics and communication engineering. So they will come under specific programs. And then course outcomes, here in this case, our course is engineering physics, which is taught for first year BTech students. Now, before going into these different outcomes, first we are going to discuss about course syllabus. Now, if I talk about engineering physics course syllabus, it is under 5 modules. In first module, we have quantum mechanics. And in this quantum mechanics, we are talking about de Broglie hypothesis, which is based on wave-particle duality. And then we have Davison and Germer's experiment, time-independent Schrodinger's equation, and then Born interpretation of wave function and one-dimensional potential box. Coming to second module, we have Introduction to Solids and Semiconductors. In Introduction to Solids, we are going to compare classical theory and quantum theory. And then we are going to discuss electron in a periodic potential, that will come under Bloch's theorem. And then chronic Penny model, which has given a way or path for the origin of energy bands. And then we are going to discuss about classification of solids into metals, semiconductors and insulators. And then coming to semiconductors, here we are going to discuss in detail different types of semiconductors. We are going to derive expression for the carrier concentration, and we are going to see what is the location of Fermi level in each type of semiconductor, and how the location of Fermi level is going to change with temperature and doping concentration. And finally, we have one application to semiconductor, that is nothing but Hall effect. Then coming to third part, here we have lasers and fiber optics. In lasers, we are going to focus on characteristics of laser, then different phenomena related to lasers like spontaneous and stimulated emission, metastable state, population inversion, lasing action, and of course different types of lasers, where we are going to discuss about UV laser, helium neon laser, and of course in the end applications of lasers. Then coming to second part of fiber optics, here we are going to discuss about principle and construction of an optical fiber, then acceptance angle and numerical aperture, different types of optical fibers, and finally application of optical fibers and block diagram of optical fiber communication system. Coming to fourth module, here we have light and optics. In this first part is interference, second part is diffraction. In interference, we are going to discuss about principle of superposition of waves, Young's double slit experiment, fringe width and Newton's rings. And coming to second part, Fraunhofer diffraction from a single slit, double slit and diffraction grating experiment. Coming to last module in engineering physics, where we have harmonic oscillations and waves in one dimension. First, we are going to discuss about different types of simple harmonic oscillators, damped, simple, forced, and also we are going to discuss different waves and their wave equation. So this is our syllabus for engineering physics. Now we are going to do course outcome as mapping to the program outcome for this syllabus. First, we are going to see what is the overview of course. What is our course, engineering physics? Now, once we look at this course overview, here as you can see that This course matter, of course, it is divided into 5 modules which will cover duly recognized areas of theory and study. This course develops abstract and critical reasoning by studying mathematical and logical proofs and assumptions as applied in basic physics, and to make connections between physics and other branches of sciences and technology. Now, the topics covered include waves, non-dispersive transverse and longitudinal waves, light and optics, wave optics, lasers, introduction to quantum mechanics, solution of wave function, and introduction to solids and semiconductors. And finally, when you just take overall view of this engineering physics course syllabus, this course it is going to help students to gain knowledge of basic principles and appreciate the diverse applications in technological fields in respective branches. And then next is course objectives. Now program, of course these are course objectives, not program objectives. So here we are talking about course objectives. And here coming to course objectives, here if you see, and of course they are about professional and career accomplishments for a particular program education objectives. But here we are going to talk about objectives related to engineering physics. And in this, as you can see, there are 4 course objectives. First one is basic for students. They are going to learn, they'll try to learn basic formulations in wave mechanics for the evaluation of energy levels and quantization of energies for a particle in a potential box with the help of mathematical description. And coming to second course objective, okay, students, after learning engineering physics, okay, they are going to learn about fundamental properties of semiconductors, including the band gap, charge carrier concentration, doping, and charge carrier transport mechanisms. And coming to third objective, students, they are going to learn simple optical setups and experimental approaches of light and laser using its interaction with matter. I'm coming to final objective of engineering physics course. It is going to help students to learn basic comparative studies between different harmonic oscillators and different waves using such relationship on practical problems. These are the course objectives. But when we talk about program educational objectives, it is for BTech program. These will represent professional and career accomplishment after 4 to 5 years of graduation. And whatever PEOs are written for a particular program, that is BTech, they have to be from different perspectives like career, technical competency, and as well as behavior. Now, these are the course outcomes which are written for engineering physics course syllabus. And whenever we are writing course outcomes, what exactly are course outcomes? These are formal statements of what students are expected to learn in a course. And when we are framing these course outcomes, there is one formula, learning outcome formula. What is that formula? Of course, here we are going to focus on 3 parts. First part is student should be able to, what he is able to do from a particular course plus its behavior. So from learning a course plus what is the final resulting evidence after learning the course. So based on these 3 factors, by putting these 3 factors together, we are going to frame course learning outcomes. So as you can see here, there are 10 course outcomes for engineering physics course syllabus. And when we talk about these course outcomes, of course, after successful completion of the course, students will be able to. Now, as you can see, for each module, we have written 2 course outcomes. So, first 2 course outcomes, they are for first module, which is quantum mechanics. And as you can see here, what is the first course outcome? Explain here what we are going to do, students, after studying about quantum mechanics, they are going to explain classical mechanics being replaced with the wave equation by using experiments that revealed the wave properties of matter. And this particular course outcome, it will come under which level of Bloom's taxonomy understand. And second course outcome related to quantum mechanics is make use of quantum mechanical description in Schrodinger's equation for simple systems and interpretation of wave functions. And this course outcome, it is going to come under the level of apply of Bloom's taxonomy. Then next, course outcome 3 and 4. They are related to second module, which is introduction to solids and semiconductors. So coming to third course outcome, here a student is going to explain the charge transport mechanism in intrinsic and extrinsic semiconductors by quantizing the charge carrier density, and this will come under level of understand, and then describe the behavior of charge carriers in a semiconductor by using the phenomenon of Hall effect. This is also under understand level. The next two course outcomes, they are for third module, which is lasers and fiber optics. So here students, they will be able to compare the concepts of lasers and normal light in terms of mechanism and working principles for application in various fields and scientific applications. And coming to next course outcome related to third module, explain functionality of components in optical fiber communication system by using the basics of signal propagation, attenuation and dispersion. And both these course outcomes, they are going to come under the level of understand. And then next, seventh outcome and eighth outcome, they are related to fourth module, which is lasers and optics. So here coming to this seventh outcome, here students, they will be able to relate the physics of interference and diffraction phenomena by using the principles of wave function and superposition. And this will of course come under the level of remember, because already at plus 2 level, they are going to study about these phenomena of interference and diffraction. So they are going to recollect those principles. And then coming to course outcome 8, which will come under the apply. So whatever they have learned in their plus 2 level, they are going to apply it. So in what way they are going to apply? They will develop an understanding of interference and diffraction phenomena by using different obstacles. The last two outcomes, 9th course outcome and 10th course outcome, they are related to module 5th, where we talk about harmonic oscillations and waves in one dimension. So coming to 9th outcome, here student will be able to explain simple systems with equations of their motion and expressions of oscillation frequency by concept of simple harmonic motion. Here student is going to understand. Okay, so what is the level which is related to this course outcome? Understand. And coming to last course outcome, this is application part of Bloom's taxonomy level, where student will be able to examine different waveforms arriving at their wave equation by using necessary mathematical applications. So total 10 course outcomes are given for engineering physics syllabus. Then coming to BTech program outcomes. So what are program outcomes? They are also called as program learning outcomes. And of course, they are broad in scope, and they usually represent what students will be able to do at the end of the program. And these POs are to be in line with graduate attributes as specified in the Washington Accord. And whatever POs are framed, they are to be specific, measurable and achievable. And this program outcomes, they are fixed for any branch of BTech. Okay, so as you can see, a graduate of engineering program is going to demonstrate following program outcomes. Coming to first program outcome, completely talks about engineering knowledge, where you apply the knowledge of mathematics, science, engineering fundamentals and in engineering specialization to the solution of complex engineering problems. And coming to second program outcome, which is for BTech program, problem analysis, where we are going to identify, formulate, review research literature and analyze complex engineering problems, and then reaching substantiated conclusions using first principles of mathematics, natural sciences and engineering sciences. And then third program outcome, design and development of solutions, where we are going to design solutions for complex engineering problems and design system components or processes that meet specific needs with appropriate considerations for the public health and safety and the cultural, societal and environmental consideration. Then fourth program outcome, it talks about conducting investigation of complex problems, where we use research-based education and research methods, including design of prediction and modeling to complex design of experiments and analysis and interpretation of data and synthesis of information to provide valid conclusions. Then fifth program outcome, it talks about modern tool usage, where we create, select and apply appropriate techniques, resources and modern engineering and IT tools, including prediction and modeling to complex engineering activities with an understanding of limitations. Now, usually For a BTech program, there will be 12 program outcomes. And out of those 12 program outcomes, first 5 program outcomes, they are technical. They are completely related to that particular BTech program. And whereas remaining 7 program outcomes, they are non-technical. So just we are going to have glance at those 7 more program outcomes which are non-technical in nature. So coming to 6th program outcome, they talk about engineer and society, where we apply reasoning informed by contextual knowledge to assess societal, health, safety, legal and cultural issues and the consequent responsibilities relevant to the professional engineering practice. And then 7th program outcome, it is about environment and sustainability, where we understand the impact of professional engineering solutions in societal and environmental context and demonstrate the knowledge of and need for sustainable development. Then program outcome 8, it talks about ethics, where we are going to apply ethical principles and commit to professional ethics and responsibilities for engineering practices. And then 9th program outcome, it talks about individual teamwork, where we function effectively as an individual and of course as a leader in diverse teams and multidisciplinary settings. And then 10th program outcome, it talks about communication, where we communicate effectively on complex engineering activities with the engineering community. And of course, it involves designing documentation, make effective presentations, and give and receive clear instructions. And then 11th program outcome, it talks about project management and finance, where we demonstrate knowledge and understanding of engineering and management principles and apply these to one's own work as a member and leader in a team. And then final program outcome, that is 12th program outcome, will be lifelong learning. So here recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. So these are 12 program outcomes. They are fixed and they will be same for any institution, for any engineering institution. Now, we have explained outcomes for a particular course, that is engineering physics. We have taken 10 course outcomes for engineering physics. And of course, for BTech program, we have 12 program outcomes, of which first 5 are technical and then next 7 are non-technical. Now, how this engineering physics course can be assessed based on these program outcomes, we are going to see here. Now, as you have seen that we have total 10 course outcomes and we have 12 program outcomes, and all those 12 program outcomes, they may not get mapped to 10 course outcomes for engineering physics. So mapping of course outcomes to program outcomes, it depends upon what type of course we are taking. But when we are talking about engineering physics course, which is basics for first year engineering students, so when we try to map those course outcomes to program outcomes, what we are going to study here is, out of those 12 program outcomes, only 3 program outcomes which are technical in nature, they are going to relate to engineering physics syllabus. So what are those 3 program outcomes? Where we are going to apply basic knowledge of mathematics and science. And here strength level is 3. What is 3? 3, it means that it goes to high level strength. So here, because in engineering physics course syllabus, we are mostly learning about basics of sciences and mathematics, which they can apply it to engineering fundamentals. Okay, so strength of mapping is 3. And how that proficiency can be assessed by presentation on real world problems. And then coming to this engineering physics course outcome, it will be mapped to second PO, which is problem analysis, where they can review research literature and analyze complex engineering problems using first principle of mathematics, natural sciences and engineering sciences. So here, what is the strength of mapping? CO, mapping to PO, strength is 2. It means that mapping is medium. And there is one more program technical outcome, which is also technical in nature, to which engineering physics course outcomes can be mapped as PO4, where we are going to conduct investigations of complex problems. Here, we are going to use research-based knowledge and research method, including design of experiments, analysis and interpretation of data, and synthesis of information to provide valid conclusions. And what is the strength of mapping? 1. So, low level of mapping. And here I have taken here in this case electronics and electrical and electronic engineering, that is for triple students. So what is the specific program I have taken under BTech? I have taken triple. And for triple, of course, out of their program specific outcomes they have, coming to engineering physics course syllabus, only one program specific outcome can be mapped to course outcomes. And what is the program specific outcome? It is to formulate and evaluate the applications in the field of intelligent, embedded, and semiconductor technologies. And what is the level of strength? Second level, that is medium level. Now here we are going to see for each outcome how these POs and POCs are mapped, and it is called as course articulation matrix. So what is course articulation matrix? Which shows the educational relationship or level of learning achieved by a student by taking relationship between course outcome and program outcome for a course. And what is the main advantage of this course articulation matrix? This matrix strongly indicates whether the students are able to achieve the course learning objectives. And also this matrix can be used for any course, and it is a good way to evaluate a course syllabus. And if you see this tabular column here, onto the left side, I have taken different course outcomes, and here we have 10 course outcomes, 2 course outcomes given for each module of engineering physics course syllabus. And coming to program outcomes, total we have 12 program outcomes, and specific outcome for this triple branch, we have 3 outcomes. Now first course outcome, it is, as you can see that we have considered out of 12 program outcomes, I have considered only 3 program outcomes which are technical in nature. PO1, PO2 and PO4. And coming to program specific outcomes, I have taken only one specific outcome, which is 1. Okay, now we are going to see each course outcome getting mapped to program outcome as well as program specific outcome. CO1, it can be mapped to PO1, PO2. Okay, whereas CO2, it is mapped only to PO1. So here, whereas CO3, it can be mapped, course outcome 3, it is mapped to PO1 as well as PSO1. And whereas course outcome 4, which is related to solids and semiconductors, it is mapped to PO1, where we talk about basics of mathematics and sciences, and of course PSO1. And then whereas course outcome 5, it is mapped to PO1, PO2 as well as PSO1, and this course outcome 6 is mapped to PO1, PO2, PO4 as well as PSO1. So this course outcome 6, it is mapping to maximum number of program outcomes and of course program specific outcomes. And then 7th course outcome, it is mapped to first program outcome and 4th program outcome. And CO8, it is mapped to first program outcome, and CO9, it is mapped to first and second program outcome. And whereas coming to 10th course outcome, it is mapped to PO1 as well as PSO1. So this is mapping of course outcome for engineering physics to program outcomes as well as program specific outcome. And here I have taken program specific outcome for triple branch. So this is about CO and PO mapping, completely based on outcome based education. Now just quickly we are going to have we are going to see about what is the evaluation methodology used here. And coming to our evaluation methodology, if you see the course, it will be evaluated for a total of 100 marks. Out of which 30 marks it is for continuous internal assessment, which is simply called CIA, and 70 marks it is for semester end examination, which is called SEE. And when we talk about continuous internal assessment, here of course it is for 30 marks and it is for a semester. And what we are going to do for this CIA, marks are awarded by taking average of 2 CIA examinations, or what we'll do, we'll conduct this entire semester where they are going to write 2 CIE examinations. We can take average, or what we'll do, of course it is for 20 marks, we may conduct 10 marks for first CIE and 10 marks for second CIE, and we can add. So it can be in both ways. By taking average, for taking average we are going to conduct CIE exam for 20 marks, okay, 2 times. Whereas when we want to combine, then 10 marks in first CIE, 10 marks in second CIE, and we are going to add these 2 CIE marks. And also we are going to take average of marks coding makeup examinations. And then coming to semester end examination, of course it is for 70 marks and it is for 3 hours duration. And here syllabus, it is, as we know that it is divided into 5 modules, and each module it is going to, we are going to give it equal weightage in terms of marks distribution. And if you are talking about question paper pattern, here 2 full questions with either or choice will be drawn from each unit, and each question is going to carry 14 marks, and there could be a maximum of 2 subdivisions in a question. And here, when we talk about expected percentage of cognitive level of the questions that are used in examinations, in semester end examinations, if you can see in this tabular column. So we are more focusing on 3 levels: remember, understand and apply. And what is the percentage of cognitive level we are going to focus? It is for remember only 7.69, which they are going to remember basics that are taught or that are learned in their previous level of education. And then understand level, which is around 54 percentage, and then application level it is about around 40 percentage. So they are going to focus more. This is for first year graduate students. And then coming to continuous internal assessment, so we can take average by conducting 2 times continuous internal examination, or we can conduct each internal examination for 10 marks and then we can add to make it 20 marks. Okay, that is continual internal examination. And then remaining 10 marks, 5 marks they are for quiz examination, and 5 marks it is for alternative assessment tool. And when we are going to see the CIE exams, it will be conducted at the end of 8th and 16th week of semester respectively. And CIE exam, it is conducted for 20 marks of 2 hours duration, which has 5 descriptive type questions, out of which 4 questions have to be answered. Each question carries 5 marks. Okay, so here marks are avoided by taking average of marks scored in 2 CIE exams. And coming to quiz, 5 marks quiz online examination. Here it consists of 25 multiple choice questions and are to be answered by choosing the correct answer from a given set of choices, and mostly will be given 4 choices. And the question paper shall be useful. What is the use of this quiz online exam? It will help them in testing knowledge, skills, application, analysis, evaluation and understanding of the students. And here also we are going to conduct 2 quiz examinations, and we are going to take average of those 2 quiz examinations for every course. And coming to alternate assessment tool, this is very important part. This will enable faculty to design own assessment patterns. And here, what is the use of AT? It will convert the classroom into an effective learning center. And what are the different AT tools chosen for first year students? Concept video. Okay, so they will be given one topic, and on that topic they are going to give PowerPoint presentation. They are going to shoot video of it, and then they can also be given assignment and tech talk. So they will be given one topic beyond their syllabus. Again, they have to prepare PPT, they have to collect data, and they have to present it in a video. And then they can also go for seminar, and also they have this open-ended experiment. So these are the different alternate assessment tools. So overall, main focus is to make a student come out with knowledge, so that he'll be able to withstand global competition. So with this, I'm going to end my session here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.